Hi, I'm Tinish, and in this video, we're going to do probability of compound events, which could either be disjoint or overlapping events. And I'm going to explain both of them in this video and how to solve for them. So, compound events are the intersection of two events. If the two events are overlapping, that means they have one or more outcomes that are in common with each other. But if they aren't, if there aren't any outcomes that are common between both the events, then they're called disjoints. So these are the formulas for both disjoint and overlapping events. So probability of A or B is equal to probability of A plus probability of B. And the overlapping is probability of A or B is equal to probability of A plus probability of B minus probability of A and B. You probably have a lot of questions at this point, like what does it exactly mean to have to compound probabilities, and what is disjoint and what is overlapping, and how do you differentiate between them? I'm gonna explain these things with different examples. So let's start with this one. Two six-sided dice are rolled. Find the probability that the sum is a multiple of 4 or is 5. So already it looks like I just combined two different probability questions and I called it a day and asked you to solve it, right? So this essentially is what compound probability is. We have two different probabilities. Probability, it's that the sum is multiple uh, of 4, or the probability that it is 5. I have two different probabilities, and I'm asked to find when either of these options will happen. So this obviously is a compound probability, but I don't know which kind of compound probability. Is it disjoint or overlapping? When I defined both of these things, I said overlapping is when one or more outcomes of these events are in common with each other. So that means I have to look at these events and see if it's possible that the sum of the outcomes of the two six-sided dice are both a multiple of 4 and 5. So basically, I need to see when I add numbers from 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6, that any of these numbers are both a multiple of 4 or is equal to 5 and is equal to 5, basically. And obviously, that is not possible because if it is 5, right, then how could it be a multiple of 4? Because 5 is not a multiple of 4. So this obviously is a disjoint. This is a disjoint probability, and we have to use this formula to solve it. There is no way. There is no way any of these outcomes are in common with either of these probabilities. And now we can find, but to do this, we have to first find the probability of both events, and then we got to add them together. So let's do that. So I don't exactly have to find the actual sum. I just need to see how many of these are multiples of how many of these are multiple of 4 and how many of these are just equal to 5. So the multiples that fall within the multiples of 4 that fall within this range are 4, 8, and 12. So I need to find numbers that add up to this. Altogether, I found 9 out of the 36 possibilities that are multiples of 4. And now to find how many add up to 5. Um, is- hmm, hmm, hmm. So there are 4 out of 36 that add up to 5. And this form, lastly, we just gotta add it up and we'll find the probability of either happening. And that's equal to the sum, which is 9 over 36 plus 4 over 36. And that's equal to 13 over 36. Of the 45 customers in a cafe, 40 customers bought coffee, 30 customers bought oranges, and 28 insane customers bought both. Who in their right mind actually buys both coffee and orange juice at the same time? We have to find the probability that a customer bought either coffee or orange juice. So basically, the same customers who only bought either a coffee or orange juice and not both. So let's start. Already, we can see that this is a compound probability because there are two events, the probability of buying coffee and the probability of buying orange juice. There's one more addition. We also have customers who bought both. So there is a sort of overlapping. So when we have people who buy coffee and there are people who buy orange juice, there are also those who who bought both. So you can clearly see that there are overlapping customers. So this calls for overlapping probability. Now that we know this information, let's go ahead and solve this. The first thing we have to do is find the probability of those who bought coffee and the probability of those who bought orange juice and subtract the probability of those who bought both. This should make sense because if you look at the Venn diagram again, let me go back to um, this should make sense because when you look at this Venn diagram, since I'm only looking for this area and this area, not the in-between area, I essentially just add both of these things. So that'll find the total area of the things surrounded by these circles, and I'll subtract this little bit that I don't want, right? So already these full circles are 40. This one is 40, and this one is 30. And I know this here is 28. So if I just subtract, if I add these 40 and if I add the probability for these two and subtract the probability for this, all I'll be remaining is the probability of sane customers that bought only one of these things. So let's do that. So the probability of uh, sane customers is equal to probability of coffee plus probability of orange juice minus the probability of both. Probability of coffee is 40 out of the total 45 customers plus the 30 for orange juice out of the total 45 customers minus the insane human beings that chose both, which is 28 over 45. I don't know why I have such extreme ideals for these kinds of math problems, but I do. Now to find the same customers, it's 70 over 40 here. 70 over 45 minus 28 over 45, and that should total us 42 out of 45. 42 out of 45 sane customers. There are 30 students in a class. 19 students choose either basketball or football. 13 students pick basketball and 15 pick football. Find the probability of overachievers in this class. Uh, that basically means students that pick both. We can clearly see this is compound probability because we have two events, probability of playing basketball or probability of playing football. So I'm going to quickly find the probability of those. So it's 13 out of 30 for basketball and 15 out of 30 for football. I'm not going to simplify this because it's easier to solve with using this form. And this this is clearly overlapping because the question clearly asks, find the probability of students that pick both. So there are students that pick both basketball or football. So if you're not satisfied with this explanation, let's look at this part of this question. So 19 students choose either basketball or football. So this is essentially our probability of A or B. I already said this was overlapping. If this was disjoint, then that means probability of A or B is equal to probability of A plus probability of B. So probability of A and B are in this situation is 13 over 30 and 15 over 30 respectively. And if I were to add them, it's not equal to the 19 over 30, which is this. So it's not disjoint. We can clearly see. So there are students that picked both, and that's what we're trying to find. So since it's probability of A or B, which is equal to probability of A plus probability of B minus probability of both. So let's fill in these things. So 19 over 30 is equal to 13 over 30, uh, 13 over 30 plus 15 over 30 minus probability of overachievers. Since overachievers is such a huge word, I'm just gonna say OA. So let's quickly solve. So 30, this is 28 over 30 is equal to 19 over 30 minus probability of overachievers. So probability of overachievers is equal to 9 over 30, which is equal to 3 over 10. And we're done.